Okay, we might begin. Thanks very much, everybody. And I wish today to begin by acknowledging the Ngunnawal and Ngambri people as traditional custodians of the land we're meeting on today. And I want to pay respect to elders past and present, and to any Aboriginal and Torres Strait Islander people joining this meeting, either here in person or online. As we share and discuss our own knowledge and practices, we need to acknowledge the deep knowledge forever embedded in the custodianship of country. So thank you. Now, before we begin the seminar today, I just want to remind the fellows of a couple of things, just a bit of housekeeping. Firstly, the ATSE Fellow Survey has been extended until the 15th of August. So if you haven't done it, could you please jump online and complete it? The feedback is very valuable to the Academy. And secondly, a reminder that the CATES meeting will be held in Brisbane from the 8th of September to the 11th of September this year. Please join us to celebrate Generations 2025 and explore what the world could look like in 50 years for climate change, global sustainability, health and medicine, and agriculture and more. We have some 20 international academies joining us, including state and federal government delegations and some sizable delegations. So it'd be great if you could join. And also thank you to Tony Hayman for being a guest speaker with Senator Ayres at CATES. Okay, so let's move to the order of today. Today is the ATSE ACT Division Seminar. It's a hybrid seminar, so welcome to all those who are with us today in the audience here in person, but also welcome to all those online. Today we're going to look at getting to net zero, Australia's energy transition and what it means in particular for the ACT and ATSE, a very timely seminar given the debate that's going on at the national level. We have 3 presentations today. There are 2 20-minute presentations outlining the challenges and possible solutions, and this will be followed by a response to those presentations. And then we've allowed some time for discussion. The ACT, the first speaker is Drew Clarke, and Drew worked in the Australian energy policy for over 20 years. He was Secretary of the Department of Energy and was Chair of the Australian Energy Market Operator, AEMO, for 6 years. He will draw on this deep experience to describe Australia's energy transition, the challenges and the opportunities it presents to Australia, and also reflect on the role for ATSE and the allied learned academies in supporting this energy transition. Our second speaker will be Professor Ken Baldwin. Ken was the director of the ANU Energy Change Institute and was a founding director of the ANU Grand Challenge, Zero Carbon Energy for the Asia Pacific. His focus is to help drive the energy transition, particularly for Australia's future export industries based on renewable energy. Describe the role of the energy transition in achieving Australia's goal of net zero gas emissions by 2050. Dr. Helen Clue will respond to these presentations. Helen was the director of CSIRO's Climate Science Centre and vice chair of the World Climate Research Programme. She'll respond to what the energy transition means for climate change and its impacts on Australia. So, if I get this right. So these are the 3 topics our speakers will be addressing: Australia's energy transition, what it means for the ACT, and what it means for ATSE. And our first speaker will be Drew Clarke. Thank you, Drew.
Thank you, Joanne, and good afternoon. I'm going to talk about Australia's energy transition from a policy perspective. I'll talk about the techno-economic dimensions of it and the political economy dimensions. I'd like to talk a little about what would success look like and what are the risks that we're facing in achieving this transition. But first, the context. First thing to be said is that energy transitions are not new. There's been many previous global and Australian energy transitions. You can generally associate them with an economic driver and/or a technology driver. The transition that we're talking about today, of course, is driven by an environmental externality, a global environmental externality. That's unusual, and it has a time imperative and that's also unusual. But the transition of energy systems from one state to a quite different state has happened many times over history. The core scenario that we're talking about, of course, within our economy is to electrify everything, or at least everything possible, and perhaps to use hydrogen for those things that we can't electrify. And how do you make the hydrogen? Well, that would be with the clean electricity. So in this move where the energy transition to a net zero emission system is a component of a move to the Australian and indeed global economy to net zero emissions, the electricity system is the most critical component. And the good news, I think Ken and I will argue, is that we have the technologies, but the economics of this is that having the technologies alone is insufficient. Some forms of policy intervention are required. So first, let's look at the techno-economic side of it. So to my mind, there are 8 moving parts in Australia's electricity transition. First, we have the early retirement of coal-fired generators. This is already well underway and is rapidly impacting on the shape of the system. Second, we've started the process of building big wind, onshore at the moment, offshore hopefully coming, and big solar. We're also building new storage and firming capabilities, batteries, pump hydro, and probably new gas as well. We have to deploy and manage consumer energy resources, rooftop solar, batteries, electric vehicles, etc. We've got to build significant amounts of new transmission systems and interconnections. We have to reform markets, the energy market, to cope with the distributed energy, to ensure capacity and security, to cope with the building of the new transition. In essence, we have to find ways of providing price signals for what it is that the transition needs. We have to electrify the transport and industry sectors. And in doing all of this, the modelling suggests we're going to grow electricity consumption by at least double. So it is a much larger electricity system as well as being a net zero emission system. Now, those 8 parts are all interdependent and dynamic. Adjustments to the speed and nature of any one of them has an impact on most of the others. You can't just set and forget any one of them. It's a complex system of systems. But when you look at each individual part, you say, yeah, we know how to do that. This is all, each part of that is doable. But of course, in doing it, we're actually working on critical infrastructure, and that compounds the degree of difficulty and the nature of risk management. The electricity system is critical infrastructure for households, for business, for the economy broadly, and indeed for national security. So we're transitioning a pretty significant part of our economy and society. So let's turn to the political economy dimension of it. The first question that comes up from a political economy perspective is, what's the role of government and what's the role of market in private sector and markets in this process? And the answer to that is actually quite contentious. Both have a role, but different actors will argue where you draw the line, how much government should do, how much industry should do. I mean, a nice generalisation in a liberal democracy such as ours is to say that governments should do as little as possible, but as much as necessary to ensure that we meet the targets successfully. But again, a cute phrase, but where exactly is that line? And that will evolve over time. But I would argue that when you're disrupting critical infrastructure and you're acting in this global imperative context, governments must be engaged. It's figuring out how, where, and when does that occur. So I see three dimensions of the political economy question. First, community engagement, and I very deliberately list this first. The social licence required for a transition of this nature is a huge aspect that we're grappling with for society in general and in particular in highly impacted regions. And highly impacted regions can be rural areas that find themselves hosting renewable energy infrastructure and transmission lines. It can be industrial areas that have got an entire economy and workforce built around emissions-intensive industries. It's the society as a whole. But the social licence is essential. Second, I'd highlight is governance structures. In the Australian system, under our constitution, the states are sovereign in electricity. The states are sovereign. This is not one of those matters like, say, communications, where the Commonwealth is vested with all of the power. In fact, the states are sovereign on onshore energy. So your governance arrangement has to recognise, work with, complement, integrate the aspirations, the legitimate aspirations and interests of all of the 8 states. And in the national electricity market that interconnects the whole of the East Coast, that's no mean feat. We've been doing it for over 25 years, but it's a complex beast to manage. And the third is that it's an orchestration problem. Those 8 dimensions, those 8 technical and economic dimensions, all have to be orchestrated in some way. Public policy, private investment, and consumer preference all come into play and disrupt those elements. How does government, how does the private sector, how does the society achieve smooth, at least successful orchestration across all of that? Now, I would argue that in thinking through the political economy of the energy transition, that there are 3 enduring principles around public policy in general that I think apply very strongly to the energy transition problem. The first is that policy is a long game. These sorts of hard public policy questions don't get resolved quickly. They don't get resolved in one political cycle. They get resolved over multiple cycles with consistent application. Policymakers and people contributing this need to be patient, they need to be persistent, and they need to seize opportunities when they come up. Now, there's a paradox, of course, because I can say, well, policy is a long game, but addressing climate change is urgent. And so there is a very deep tension in the energy transition between the reality of public policy in a liberal democracy and the urgency of addressing climate change. The second principle is that evidence beats ideology, mostly in the long run. And so you could probably think of some examples where it hasn't, but by and large, evidence prevails and beats out ideology. But it can take quite a while to build it for that to occur. And social licence is a big part of that. The third principle, I would argue, is that institutions matter. Institutions play an important role in this. To build and sustain independent, objective expertise is a critical part of dealing with complex public policy. I look in the energy transition space at bodies like ARENA, that has been there for the long run, supporting research and demonstration projects. I'd like to think that the body that I chaired for a while, the Energy Market Operator, is an example of an independent expert body contributing to this. And I think institutionalised reports such as GenCost, led by CSIRO, is a critical part of how we manage the energy transition. And we'll come to this a bit later, but I think ATSE can also be one of those institutions that can play a role that transcends the political cycle and sees through the disruptions and interruptions that are inevitable. Success. What would a successful energy transition look like? Well, it's got three dimensions. It's got an environmental dimension, which is pretty obvious. It's got a social dimension, and it's got an economic dimension. And within electricity, that's normally encapsulated in the energy trilemma. Emissions, we need a net zero energy electricity system by a date. The current chosen date is 2050. And to achieve that, we have to transition the system faster than any previous energy transition. The scale and depth to achieve the current target date is harder, more difficult than those previous transitions. But the emissions objective is very clear and measurable. Second, prices. Prices for households, prices for industry, and how energy prices interacts with our exports. A critical dimension. And the third part of the trilemma, I'll concatenate reliability and security. They're not the same thing, of course, but the simple meme of keeping the lights on is a function of reliability and security. I think of the goal of the energy transition from a policy perspective, a domestic policy perspective, as to rebuild Australia's national competitive advantage around low cost, low emission, abundant energy. We had such a situation 20 plus years ago. We need to get back to where that is a core part of the Australian economy and society. And the fastest way to lose the social licence to achieve that outcome is high prices and blackouts. So these things are all related. We have to achieve the transition, keeping the lights on, keeping prices down, and reposition the Australian economy as at the end game. Risks. This is an environment in which the risks are obvious and clear, but let me pick out three that I think policymakers grapple with and that are critical to this. First, there is, I think, an unrealistic expectation around the planning of this transition. I think there is a sense in many parts of the community that the energy transition can be planned. You know, here's the blueprint, now just go and execute it. And at the end, you launch it and we're off. It's far more complex than that. It's not a linear process. There will be bumps along the way. And on almost any day in the media at the moment, you can read about another bump that's occurring in this process. It's one of the reasons why one of the core documents guiding the transition, and I'm using that word guiding deliberately, is called the Integrated System Plan, but it's not a plan. This is the document that AEMO produces every 2 years. Every 2 years, so much changes that this guiding document needs to be remodeled, reconsulted and published again. And the moment it's published, AEMO starts the cycle again. Indeed, there have been some suggestions that it needs to be annual, such as the rate of change. So it's not a linear process, and that's not always understood. I think audiences such as ATSE understand that, but I don't think it's well understood outside that. The disruptions come from multiple directions. There can be political disruptions to this process. There can be geopolitical disruptions to it. Supply chains can be interrupted and change. Labour and skills can be impacted. Technology itself will change, and we want it to change and improve within this cycle and disrupt the transition. And of course, perhaps ironically, the climate itself is a disruptor of the energy transition, and our understanding of that and how we manage in that is still evolving. The second risk is around implementation. So in that context of disrupted, bumpy process, the implementation risk, the biggest one, is a collapse of community support. It's basically the community saying, you know what, this just isn't worth it. We're paying too high a price in whatever definition of price you want to pay for this. And that can be around the cost of electricity, it can be reliability and security, the blackouts, it can be local impact on jobs and infrastructure. But a collapse in community support, in social license, is a risk that has to be managed for continuously. And the other obvious implementation risk is simply around delay. You know, given the time imperative that is imposed on this transition, planning approvals, regulatory approvals, construction delays, all compound that problem, the implementation risk. And finally, I would argue that there is a strategic risk context to this. There is a broader argument of, if Australia doesn't do this, or if we're too slow to do it, where does that leave our economy in a broader global context? That's a big strategic dimension. As we implement it, there are strategic risks around who owns these new elements of the energy system. Who's the asset owner? Who's the asset operator? The companies and the kit that we're using. We're changing that quite quickly, and there are risks associated with it. And I think there is a digital risk. The communication system and the energy system are codependent. The digital disruption is impacting the energy system as much as any other part of the economy. And you can think about geopolitical players, criminal players, and the way in which communications, data, artificial intelligence can all impact on the electricity system. So that leaves the question of, well, where can ATSE play in this world, in this policy world? I expect that my colleague Ken will jump in and have some very specific suggestions on this, but I'm going to address it just from that policy perspective that I've given you an outline of. Science, technology and engineering. What do the scientists, the technologists and the engineers have to say about this? I think ATSE's positioning on this should be along the lines of, we know how to do this energy transition. Yes, it's big, it's complex, and we're under pressure to do it faster, but we know how to do it. It's not, the risks are manageable. The risks are more in the political economy, community engagement area than they are in the technical and engineering area. This is not a wicked problem. We have wicked public policy problems in Australia. This isn't one of them. We know how to do this. And our positioning in arguing that should be, we need to associate and work with our social science colleagues to integrate that science, technology, engineering perspective with the social science, social license dimensions to achieve it. So somewhat ironically, ATSE would be saying, this isn't a science, technology, engineering problem alone. Our role is to say, we know how to do this. We have the energy, the engineering, technical expertise to make this happen. We need to work with social scientists and communities in maintaining the community support and overcoming, managing those risks and ensuring that the political economy dimensions work for the energy transition. Thank you. That's a quick walk through the policy perspective. And I'll hand to my colleague, Ken, who will take you deeper into those technologies and pathways.
Thank you, Drew. And as advertised, I'll be homing in on the progress in the ACT as far as energy transition is concerned. But let me first of all pick up from the national perspective that Drew was talking about and tell you a bit about where Australia stands at the moment. So here's an interesting indicator of where we are internationally. This shows the number of watts per person, very important, watts per person of installed renewable electricity capacity in 2023. And as you can see, Australia is amongst the leading pack. And if you take into account the fact that Australia's solar resource is probably 50% higher than most of the Northern European nations that are on the in the same group, then you can see that we're ostensibly world leading in terms of the rate of the transition in Australia, not the level of the transition, but the rate. That's a very important number. So we are facing the sorts of problems and challenges that all other countries will face probably earlier, simply because the rate of our transition is the highest, and also because we are an island nation. We have to solve this problem on our own. We cannot import energy from other countries locally in the form of electricity. Just to give you some numbers, Australia is installing more than 6 gigawatts per annum of solar and wind, and has done so for the last 7 years, a record of 7.5 gigawatts in 2024. We've now reached more than 40% of electricity in the national electricity market, and sometimes this peaks at around 75%. And more than 1 in 3 houses, i.e. more than 4 million homes, have solar on their roofs, and this is world leading yet again. If we look at the renewable energy pipeline, these are figures from the regulator. What we see is that this level of around 6 gigawatts or so per annum for the last 7 years is continuing. There's last year, and it is sort of, slowly creeping up, if you like, as we increase the percentage of renewables in the national electricity market, which you see as the top line. I could make a lot of comments about why it is that it took so long for us to get there and to start increasing this installed capacity around about the 2017 mark. And as you can see on the left, a large part of this was due to government policy uncertainty, with about the only certainty in the system being the renewable energy target. We're going to have that discussion later. However, the key thing is that while this is a very rapid rate, and indeed world leading, as I said before, we need to probably double that if we're going to reach the government's target of 82% renewables by 2030. Now, that is not a big ask. We've more than doubled it over the period since 2017, so we can more than double it again. But as Drew pointed out, there are a lot of things getting in the way, and they are not technology challenges. They are social and human dimensions of the energy transition, and also political and regulatory dimensions of the energy transition. And as Drew mentioned, we're going to have to not only convert the energy sector to completely renewable electricity, but as we do so, convert all other energy uses in the economy to renewable electricity. So stationary energy such as heating and heat pumps, transport through electric vehicles, fugitive emissions by using less fossil fuels as we go along, and of course industrial emissions, which are actually quite hard. And that covers pretty much 80% of Australia's emissions and leaves only agriculture and waste and land use change as the remaining ones that are very difficult to address and very difficult, or if not impossible to address, just by using renewable electricity. And as Drew pointed out, this means that we will have to at least double, if not triple, the amount of electricity that we generate, and this all has to be through renewables. And just to take a graph from a publication that Drew and Paul Graham from CSIRO have produced, this shows how Australia has transitioned ever since we started out as a collection of states back in the 1900s, and then gradually became more and more connected, and hence the development of the national electricity market at the turn of the century. And as you can see going forward, there is the integrated system plan that AEMO have produced, as Drew mentioned, that is renewed every 2 years. And this shows going forward how the energy mix will shift away from fossil fuels, that's principally black and brown coal, you can see there, and gas, towards renewable electricity produced by solar and wind, with some small amount of gas in the system remaining to provide peak capability. And just to bring this home locally, the ACT became the first Australian jurisdiction to achieve 100% renewable electricity, and it did so in October 2019. It is still in the box seat as far as having a completely renewable electricity supply, and it has done that through a series of reverse auctions where it's purchased both solar and wind. Solar partly located in the ACT, wind almost exclusively outside the ACT, and it did so as an early mover and was able to grab, if you like, some of the low-hanging fruit in terms of the best renewable resource. And because it's a small jurisdiction, it slid under the radar and was able to do so very rapidly. All other states are now trying to do this. It would be much harder if the ACT tried to do this right now. So if we look at the ACT's emissions over time up until the previous financial year, you can see that there was a massive drop in the emissions due to the fact that the ACT became 100% renewable electricity in 2019. But there is still a lot of progress that needs to be made in ground transport in the blue, in other fossil fuel combustion in the dark blue, and ground transport and aviation. All transport forms really are dominating this particular picture. So still there is a lot to do in the ACT, but there is a plan. There is a plan going forward to do that. If we look at where the ACT lies in regard to the other states, then what we see is that, with the exception of Tasmania, that the ACT has the best record in terms of renewables progress. I think Tasmania relies a lot on the effects of land use change to get to a negative position there. I like to take the view that we should ignore land use change in all these numbers and look at the underlying economic emissions of the functioning economy, because the land use side of things goes up and down and it depends on external factors largely. But the human economic activity is reflected in things like transport, electricity, etc. So the ACT is doing very well and is well ahead of the game in that regard in terms of emissions per capita. So the ACT, and you can see all these graphs and figures, by the way, on the ACT government's website. It has a target looking forward that is based on 100% renewable electricity continuing over the coming decades. New capacity, of course, needs to be brought online to accommodate increased population growth and economic activity. And this has to be coupled with batteries to make sure that we have the ability to deal with demand at all times of the day and not just be net zero on average over the day. a third of ACT homes, like the rest of the nation, have rooftop solar. And indeed, if you look at the residential rooftop capacity of 374 megawatts, what we find is that if you average that out amongst the population, that's around 1 kilowatt almost of installed rooftop PV per person, which is getting close to providing a significant part of our electricity needs on a daily basis. And of course, the rest of that is made up for by the renewable capacity that is brought in from outside the territory. In terms of moving the dial on these other areas, transport is the largest one, as I pointed out. And here is a graph of quarterly electric vehicle sales in the last quarter of 2024 and the first quarter of this year, in light blue and dark blue respectively on the top graphs, and similarly on the lower graphs. And what we see again is the ACT leading the pack. So in terms of battery electric vehicles, we are the clear leader with around 16 or 17% of the vehicles being sold in that category. With plug-in hybrid electric vehicles, so in other words, with an internal combustion engine, but with a battery you can plug into the mains, we are leading with around 7 or 6%. And hybrid electric vehicles, very similar to the rest of the country. So these are electric vehicles with regenerative braking, et cetera, to charge your battery that run mainly off the internal combustion engine at other times. And we're similar to the rest of the nation at around 19%. If you add all those numbers up, we're approaching 50%, of the vehicles sold in the ACT having some form of electric propulsion. So that is very commendable. And indeed, the ACT is moving in that direction in terms of encouraging electric vehicle use. And that is, again, one of the key elements of its emission reduction plan, given that the electricity here is 100% renewables. Interestingly, a recent study that was published by a group at ANU showed the enormous capacity that this then gives us for storage in terms of the electric vehicle battery. So the electric vehicle battery is enormous. It's much bigger than any battery you would ever install in your house. So that begs the question, why would you install the battery in your house when you can buy an electric vehicle? Well, the answer is that not every vehicle is set up for two-way flow, and not every jurisdiction enables two-way flow in the distribution network. So, we have an enormous resource if the ACT continues in this direction. So this indicates the geographic spread of EV storage capacity, assuming that we go down this route and decarbonise the transport system. And it compares it with the hot water storage capacity you typically would have in your household. So this is a, 300-litre tank that you heat with a heat pump or whatever, which is a terrific storage mechanism, right? You run it off your solar during the day, store all this energy at night, and then use it at other times. So that is already something that many people do. How many people in this room, for example, have solar on their roof? Just about everyone. How many people have heat pumps to heat their hot water? Yep, a significant number. And so this means that you are part of the little orange wedge in these graphs that is able to do that. But look at that compared to the blue part of the circles, which is the battery electric vehicle capacity. And that shows how consumer energy resources will play an enormous part in helping the energy transition move forward. So just to close off on the ACT, the climate strategy going forward is net zero by 2045 in these various stages. And if we look at what that means in terms of decarbonisation, this is business as usual. You can see the big step change that happened when 100% renewable electricity was realised in 2019. And then the remaining sectors that need decarbonising are gas, transport, waste, and industrial emissions in red at the bottom. So that is what business as usual could mean. You can see the targets that are superimposed over that. So that means that we need measures to make sure that those targets are met. So transport abatement is going to be one of the biggest ones, and that means continuing the shift to electric vehicles. And I would suggest to battery electric vehicles rather than hybrids, because hybrids don't do the job. Then there is a significant shift in our waste and also in our industrial emissions. So that means using heat pumps and other sources to electrify the emissions from industry in the ACT. And the end result is that with all of those elements addressed, this target of 2045 could indeed be achieved. So the ACT, I would suggest, is very strongly focused on moving down this trajectory, and it has the ability to achieve these goals through the mechanisms that everybody else in every other jurisdiction in Australia needs to adopt as well. Let me just give a plug for one element of the ACT's policy. This is the ACT Energy Innovation Fund, which I chair with an industry advisory board that decides on the outcomes of the fund. This fund was established as part of the ACT's reverse auction process, whereby the successful bidders all contribute funds towards innovation in the ACT. And this innovation has to either be relevant to the ACT, occur in the ACT, or have a large part of its effort devoted in the ACT. It supports technology, it supports policy innovation, it supports the innovation ecosystem in the ACT, which is actually growing quite strongly. And the idea is then it supports this energy transition strategy going forward. So those of you involved in energy research, I would strongly encourage you to look at this fund and to put in applications which aim to provide the research needed to underpin the energy transition in the ACT, because this is a very prospective opportunity. We have $17 million to allocate over 5 years. So this contributes quite a lot of money to innovation in the energy transition here in the Territory. So now let's change topic and move on to what this means for ATSE. So as we know, ATSE has its current net zero statement. This is in the document, Becoming a Net Zero Nation. And as it says in the document here, ATSE calls for more urgent action, a commitment to achieving net zero emissions by 2035. And I think that we've seen in recent years that the challenges facing us in this energy transition are increasingly more difficult. Drew has outlined some of the techno-economic issues that we face and the human and social license side of things. And so just understanding that technologically we might be able to do this by 2035 is not enough. So currently the position statement is under revision, and indeed this is a very timely thing, because the government will need to pronounce on its new nationally determined contributions for reducing emissions as part of the Paris Agreement, and it needs to do this around the sort of September 2025 timeframe in order to articulate the emissions reduction over the next 10 years. So ATSE's reconsideration of its statement comes at a timely moment when we can help contribute to this from a science, technology and engineering research point of view. And indeed, ATSE is not alone in this. So all the other learned academies have contributed to the ACOLA Energy Transition Research Plan. Drew was the first chair of this planning committee, and I've now taken over from Drew. The research plan has its aim to identify the key priority areas in research that will underpin the energy transition, for which we've identified 3 themes: energy system dynamics, which is mainly technology oriented; social engagement dynamics, which, as you can understand, is around the social sciences; and then transition dynamics, which is a combination of all of those areas. And that's why it is an ACOLA project, because all academies contribute their understanding to this process. So the aim of this originally was to guide research prioritisation in this area, and this is becoming increasingly important as we realise what the challenges are that get in the way. So we published this first back in 2021, along with, in black you can see the 4 detailed theme areas underneath. I'd like to highlight, though, the second report, Australia's Funding of Energy Research, Quantum and Comparison, which talks about where Australia stands internationally in regard to its research funding. So I'll go through that now. And indeed, this has been recently updated for the strategic examination of R&D, which was published. Actually, all the submissions of that were published just this week. So you can read that there. Let me start by pointing out that the International Energy Agency accumulates data on research in the energy transition in all its member countries, and Australia contributes to that. I've visited the IEA and discussed Australia's contributions to that compilation of data. And what it shows is that pretty much across the board in all major economic areas in the world, the amount of government spending on energy R&D has increased since around 2015. Australia is lumped in with Japan, Korea and New Zealand, in that graph. And so it's hard to determine from that what our relative contribution is. So we've analysed that based on the figures from the Department of Climate Change, Energy, Environment and Water that report to the IEA every year. So the Energy Transition Research Plan has done this analysis, and this graph shows the result. So what we've done is we've compared Australia, which is the dotted line, with our major international comparators. Okay, so we've got Germany, Korea, United Kingdom, Canada, Japan, Norway, and the United States, all on the same graph. And as you can see, we are now at the bottom of the pack, not just by a small margin, but by factors of 2 and 3. And this wasn't always the case. At one point, we were in the middle of the pack. You can see here the time frames. Here's the 2007 election when Labor came to power. Here is the 2013 election when the coalition took over. And since that time frame, research funding by government in Australia for the energy transition has gone dramatically downhill. It has not changed very much in recent times. We don't have the very latest figures, so that trend is hard to ascertain. But you can see that these are the major shifts in government over the period that is relevant to this data. So this tells a story, and the story is not a good one. Australia is, even though it's leading the world in terms of the rate of the energy transition, it is lagging the world in terms of the amount of money it's willing to put into research to underpin that transition. So during this time frame, it is in fact quartered. So that is not just a small blip. If you then look at how these countries prioritise that amount of money that they spend, which is a different picture, what you find is that Australia is again at the bottom of the pack, and indeed we have gone down during the time of this study. So we are now deprioritising energy research compared to where we were back in 2013. And not only that, but we have deprioritised energy transition research funding compared to other countries, some of whom have increased it as a priority. And one thing that we might want to consider then is what is happening in the private sector. Now, we don't have data on that, but what we do have is data on the research and development tax incentive that is accessed by large enterprises. And this graph, which is provided in collaboration with John Howard from the Acton Institute for Policy, Research and Innovation, this shows the different sectors of the R&D tax concession that are spent over time. And the energy one is the one in purple. And you can see that although I'm not saying there's causality or anything other than correlation here, this has also decreased by a very large amount over the same time frame as government funding has decreased. So private sector investment in the energy transition in Australia has gone down in terms of the amount it spends on research as claimed under the tax concession. There might be a lot of reasons independent of government decrease in spending over this time. For example, there are many large international players in the Australian energy sector now, all of whom do their research overseas. That might be one reason. There might be a range of other reasons, such as government policy uncertainty, driving R&D out of the system, et cetera, But nonetheless, what we've seen is a decline in the private sector investment in R&D as well as in the government sector. And this does not bode well for Australia's future performance in the energy transition, where we need to know a lot more, not only about the technology, but about the social and human dimensions of the transition. So let me just let you know that ACOLA is planning an energy transition research summit. This is not about funding, although this will clearly be an elephant in the room. It is about working out what Australia needs to do in terms of energy research over the next decade in order to reach the government's stated goals of emissions reduction by 2035, which they need to announce around about September this year. So I haven't got an exact date on there, but we're kind of thinking October for this summit, and it will draw together the key energy research institutes in Australia, including CSIRO and the Energy Research Institutes Council for Australia, ERICA, and others. It'll bring together industry peak bodies and indeed state and government departments and funding agencies. And the aim is then to have a meeting over one day after the government's NDC announcement in order to look at what are the key research challenges that we need to solve in the next decade in order to make this transition happen. And the outputs will be a communique immediately after the event summarising these key challenges, and then an update of the Australian Energy Transition Research Plan for the coming months following the summit. So that's the end of the formal part of proceedings today, and I believe we now pass on to Helen Clue, who will talk to us about what this means from a climate perspective. Thank you.
Thank you. I just need to, do you do this, Luke, or do I do this? Oh, there we go. We're all good. Thanks. Thanks very much, Drew and Ken. So from the perspective of a climate scientist and the perspective of the Earth's climate system, I'm here to give a response to these two really both informative and provocative and talks from Ken and Drew. And I have, as I said, two overriding perspectives here. I'll just make sure. No, all right, try this one. Right-hand button. Nope.
Yeah.
There we go. Oh, gone too far. Thank you. Sorry about that. So the first is that as important and absolutely important as the technological, the political and policy and economic dimensions that Drew and Ken spoke about, I feel that it's equally as important to not lose sight of the why for the energy transition, especially when discussions about its relative costs and benefits become very politicised, as happens often in this country. So that's my first overwhelming or overriding response. And then secondly, and Drew sort of touched on this really, but this is sort of in my words, I sense this dissonance which confuses me sometimes in the Australian community at large, which is that on the one hand, polling and so forth demonstrates that Australians really do care about climate change. They accept it, they know it's real, and they really want to do something about it. But at the same time, we see this concern by communities about the cost of climate mitigation and the cost, therefore, of the energy transition. And as Drew said, is a lack of social license, or I think clearly a lack of social license, is really threatening to impede what we urgently need to do. And I think a contributor to this, and Drew spoke to many of the dimensions of this, for me, I feel like we are failing to appropriately put a cost on mitigating climate, or comparing that cost of mitigating climate change today compared to the risks and costs of unabated climate change by the end of this century. And so kind of my response to that is to ensure that we've got good climate literacy. We understand about what net zero means for climate, what climate change looks like, and how climate change itself will affect the energy transition. So I'll talk about that today, but I'll also talk briefly, and this is just my little schematic to try and characterize this nexus between the social license, public acceptance problem, what can we do about it, the fact that I think we need to build better literacy, but we also need better tools, better frameworks, better analytical tools to adequately capture these relative costs and benefits so that we're doing a better assessment. So I'll try and touch on that today as well, and I'm going to try and keep this pretty short. I should say that my response is about restating why the energy transition is critical. Many of you know this, and this is kind of reprising stuff that you already know. But I will provide an update on the state of the climate briefly, and then I'll have some commentary on this disconnect. So I'm conscious we've got some climate stars in the room, and I'm stealing some of their slides from an early presentation, but I really did want to go back to this, not losing sight of the why. So the scientific basis for decarbonising our energy system really begins with this observed near linear relationship between our cumulative carbon dioxide emissions on the x-axis and the warming of the planet's climate system on the y-axis. The black line here, you've all seen this plot, I'm sure, shows our observations, and the coloured wedges going out into the future shows the relative warming levels for different levels of cumulative carbon dioxide, and it tells us two really obvious points. Apart from the fact that warming is dominated by cumulative CO2, every tonne more that we add adds to warming, and that if we want to stop warming, we have to stop emissions fast. So we know that. This robust linear relationship then shows us what we need to do to limit future warming and climate change. And I know you know all this, but let's just restate this. We need to reach net zero greenhouse gas emissions by mid-century to stabilise global temperatures, thing one. Thing two, if we wish to stay below the global temperature targets as set by the Paris Agreement, so 1.5, 2 degrees, that requires that our emissions of CO2 remain within a finite carbon budget. And then the third obvious conclusion is that we absolutely need rapid, large and sustained reductions in all of our greenhouse gas emissions, not just CO2, also the methane and nitrous oxide, which is so important for near term in terms of limiting warming. So these are things that, as I said, I know that you know. In short, every 1/10 of a degree matters. The faster we reduce emissions, the much less will be the costs due to long-term, or in the long term, due to damage from climate change. Longer delays will require that we reduce emissions even faster, and we will have to rely on negative emissions technologies, many of which are still unproven at scale. And as Ken and Drew have said, we know how to do this, but we need to do it fast. Delaying has a moral dimension to it, in my opinion. It means that we're burdening future generations in terms of the risks they face and the adaptations that they are going to have to make. And from a moral perspective, that concerns me at least. So this then is the physical basis that underpins net zero policies, whether they're implemented globally, nationally, or at a state base, as Drew and Ken have very articulately explained. I just want to be really clear, this goes to the climate literacy. When something gets politicised out in the public domain, shorthand language is used, and I'm sometimes nervous that not only have people lost sight of why we keep talking about net zero in an election campaign, that it's actually about climate change, which, remember, Australia, you care about a lot, but that we use shorthand and we forget what it means. So I've reminded us that net zero emissions means balancing our CO2 emissions by human activities with removals over a specified period. And we will reach net negative emissions when those removals exceed the emissions. I know it's obvious, but it's important to just restate that. And so we have at a national level, Australia's net zero plan, which is the current government's plan for reaching its legislated target of net zero greenhouse gas emissions by 2050. And that's the illustration on the right-hand side, which I've also borrowed from the Climate Change Authority Sector Pathways Review, which Will Howard, who's in the audience, presented on in February. It shows the trajectory for a world consistent with around 2 degrees warming, the trajectory in the gold, and the different colours of the bars show the reductions in emissions for the different sectors, along with the removals that we're going to need. Okay. And then, as Ken has very well explained, ACT itself, of course, has committed to a net zero emissions target by 2045, so more ambitious than Australia's, and has already met its emissions reduction target for 2025, as Ken has explained. So I don't need to go into that in any more detail. So let's move from carbon budgets and emissions to the climate. All key climate change indicators continue to reach record levels. That's the headlines. The background concentrations of the 3 key well-mixed greenhouse gases are at their highest levels for millennia, if not millions of years. The rate of increase shows no sign of slowing of CO2 concentration. And if you cast your eye to the bottom graph there, that's hourly background CO2 concentration measurements, actually from one of the observatories in Australia that contributes to the global network. And if you look at the black box, you can see the decade to decade increase in CO2. There is no observed slowing in CO2 concentrations. For the warming, then we see the planet is warming. As of 2024, the long-term warming falls just below the 1.5 degree guardrail that the Paris Agreement set. The estimates of that vary between 1.2 and 1.4. So we're just below. We will exceed 1.5 in the next few years, absolutely. 2023 and 24, as many of you astute listeners, observers will know, was a record heating year, broke all records at 1.55 degrees for 2024. This was actually above what we would expect for greenhouse forced warming, and it shows us, it reminds us that we don't fully understand yet everything about the climate system. It's not a set and forget. It can still surprise us, so there's more work to be done. The oceans take up about 1/4 of our anthropogenic CO2 emissions. That sequestration of carbon or absorption of carbon dioxide into the ocean water changes its pH, leads to the phenomenon we call ocean acidification, which is happening in the global oceans. The oceans are also taking up some of the extra heat, well, actually, most of the extra heat in the climate system, over 90%. And so they're warming. This combination of acidification and warming is a stress factor for all of our marine ecosystems, leading to more intense and frequent coral bleaching events, marine heatwave events, as well as changing the way that the ocean circulation works, which is affecting our weather and our climate, and indeed can risk the sink strength that the oceans already have. A warming ocean is an expanding ocean, so global sea levels are rising and that rate of rise is accelerating. The cryosphere, that's the frozen part of the planet, is also affected. We see sea ice extent both in the Arctic and the Antarctic. This plot is for the Antarctic, reaching record minimums over the last few years. We have concerns with our shrinking glaciers on the land and declines in ice sheets, which will contribute to sea level rise. And I just want to remind us that these record levels that I've just taken you a quick tour through are already being experienced with global warming levels just less than 1.5 degrees. Australia's climate reflects these global changes that we're seeing. So this is from the Australian State of the Climate Report. Australia has warmed by just over 1.5 degrees from 1910 when our records began. Our sea surface temperatures have also increased, and the impact of this warming is leading to increases in extreme heat events in our communities and our ecosystems, both on land and in the oceans. And you probably are aware of some of the extreme marine heat waves in the Ningaloo area off the northwest coast of Australia. And of course, we have a huge algal bloom happening off South Australia at the moment, and marine heat wave impacts are one of the contributors to that. The observed long-term warming is in the time series that you can see. The black smooth line is the 20-year average temperature change, reaching that 20-year average of 1.5 degrees now. The projections of Australia's average temperature over the next 2 decades are shown in the gold shading, and that's regardless of the emissions scenario for those next 2 decades, showing that warming will continue, reaching probably around 2 degrees by mid-century. It means that an average or even a slightly cool year in the middle of this century will be warmer than the record warm years that we saw in 2019 or 2013 or 2005. All aspects of Australia's climate are being affected. These impacts are already being experienced, as the chart or the graphic there shows you. Those are some of the effects on various aspects of Australia's climate. Beyond 2050, if we continue on a trajectory of higher ongoing emissions, the things that you can see there in the little post-it notes will continue to get worse or more frequent. If we are on a lower emissions trajectory, then we will reduce some of those impacts. We're talking about the ACT, so I thought it was very appropriate to produce just one example for the ACT. So this is the additional number of hot days above 35 degrees projected for a low emission for the ACT, for a low emission scenario and a high emission scenario. So we can expect to maybe double the number of hot days by the end of the century for the ACT. So the energy transition absolutely is clearly required to stabilise the climate, but how might climate change disrupt the energy affect the energy transition? And Drew has already drawn our attention to that. Australia's economy is already extraordinarily dependent on the weather. We all know that. The shift to renewables means that our energy supply will be more reliant on weather resources, i.e. wind, sun and hydro, than ever before. So the weather will shape our future energy demand and our energy supply. But the fact that Australia has been dependent on weather for much of its resources and its economy for so long means that we do know how to deal with this. We build dams to store rainwater. We build battery storage systems or hydro to store energy. So we know how to do this. As Ken and Drew have said, we have the technology. However, if the weather systems themselves are responding to a changing climate, then the nature of that variability might change. And so this is, if you like, a grand research challenge, in my opinion, as to how the weather will change with climate change. This will be important not just for our food security and our water security, but also our energy security. But fortunately, a new research effort has just started late last year or during last year, which has the goal of advancing our knowledge and the models and the tools that we need to better understand this challenge and use that information to inform the energy transition. And, you know, confession, I'm part of that centre, but I wanted to draw your attention to it. So this is my last point that I want to make. And it goes back to this point about climate risk, or risk, perhaps more generally, I should say. So clearly the impacts of a high emissions world for Australia are huge. All of our economy, across all sectors of our economy, are going to be affected. Our communities, our ecosystems and the services that they provide. So we really do need to think about how do those risks and costs compare to the costs as well as the opportunities, a negative cost, of the current energy transition. And I was really intrigued to see, and I don't know how many of you saw this, the, what do they call, the UK Office for Budget Responsibility, just produced a report a couple of weeks ago where they redid some analysis factoring in the cost of climate damage, showing that actually reaching net zero quickly is cheaper than allowing unabated climate change to the end of the century. That was for a world of around 3 degrees warming. So what tools do we need? Well, I would say this, wouldn't I? I'm a climate scientist, but we do need a credible climate science capability, particularly our modelling capability, so that we can turn emissions into future climate simulations, so society knows what choices they're making. And we're really lucky because that capability has been built around the world over the last 4 decades through collaboration and strategic national investment here in Australia. Australia has actually built what I regard as a world-leading climate science capability that's across observations, process studies, and our modelling. And I just want to give a shout out to the National Climate and Weather Model called ACT. This capability is really important for informing our domestic climate policies, framing the choices that we have going forward in terms of future climate, our risk assessments nationally, and our climate adaptation planning. It's also important in terms of our relationship in the broader region, in the Pacific, Southeast Asia, as well as the Southern Hemisphere. But what's missing? Well, there's lots of things missing, but a couple that I want to comment on and bringing us full circle round to Drew and Ken's point, is that physical climate models aren't enough. They need to connect to simulations, model systems of other human economics. But even then, model data isn't knowledge, it's not information. So we need tools to turn that into information that's usable for decision making. But the big thing that I want to plug, and Drew's gone there, as have Ken, is that we need to build capability in our social sciences and our connections to those capabilities. And I think that that is critically important so that we're doing a good job of assessing these relative risks that I've talked about, and to strengthen as well our climate literacy and the way that's communicated. So ongoing climate action requires Australia to really hold its foot to the floor in terms of the energy transition. We know how to do it. What can ATSE do to help address some of these tools and things that I think are needed? Well, here are some things that I've thought about. I think ATSE can play a role in continuing to make the case for the need for R&D across all aspects of the energy transition. Ken's spoken about this. Ongoing investment so that we do sustain in an enduring way and nurture our sovereign climate science capability. This is at some risk, I have to say. And ATSE, I think, can continue to support the role that Australia plays, whether it's as a leader or as a partner with others in our region and globally. And then secondly, I think ATSE has a role to help lead or drive partnerships to strengthen connections to the social science capabilities, because as Drew and Ken have said, physical sciences and engineering are not going to be enough to get us through the energy transition. And we need to do that because we do not want to live in a world for our children, our grandchildren, that looks like the world that our climate models are telling us it would look like. Thank you.
Well, thanks very much. That's very stimulating sort of talks. What I'd like to do is open the floor for questions. But first of all, I'd like to ask a question, which I posed to the group last Friday, which is, we see in recent media reports about the potential impact of artificial intelligence consuming vast amounts of electricity. How do you see that in terms of the transition to net zero? What is truly the impact of new technologies, which may be energy intense? Is that true? And how do they fit into the system? So, Ken, do you want to?
Yes, certainly. I'm happy to kick off. So AMO just recently released a study on artificial intelligence and data centres, more broadly speaking, and the role that they would have in future demand. And the indications are that of order of magnitude, that this will contribute something like 12% of electricity demand in a couple of decades, which is enormous. I mean, that's a huge contribution, but it's not dominant, right? It's not double. So I don't want to overplay this as an issue that needs to be addressed. However, what I would point out is that this also provides an opportunity. Data centres require dedicated, constant supply of electricity. This can improve the opportunity for decarbonising the electricity system because what will happen is they will develop their own wind and solar and batteries in order to meet this demand with some backup from the grid potentially. But this will probably drive down the cost curve, these technology costs for the rest of us, and they can also act as a supplement in some sense. So, for example, I've talked to a number of developers. They are thinking that in the middle of the day when they have spilt solar, because they've got these vast dedicated facilities, they could use this to produce thermal heat for other industries or for cooling the data centres or for other purposes. So this actually is not the problem that people are making out to be. This could actually be part of the solution.
Who do you want to comment or?
Well, agreeing with what Ken said, a way to think about it from the system operator's perspective, big new sources of 24/7 load that also, for economic reasons, will want that to be clean, want it to be net zero emission load. This is a gift. This is actually helping stabilise and manage the energy system. And there'll be lots of other sectors in the economy as they electrify and create more demand. But data centres, I think, is a good problem to have.
Yeah. Please.
Yeah, I just want to follow up. Actually, we're focusing on a little the negative aspects of all these data centers, artificial intelligence, but at the same time, these new systems can be a really good contribution to manage these very complex systems we're going to put in place and manage the demand and supply in ways that we cannot even dream now. So I think that there's a huge opportunity there to actually cut and make the whole system much more efficient.
And that was a point, thanks, Pete, that was a point I wanted to make as well, Joe, is that I think artificial intelligence is actually going to be part of our solution. And to hear from Ken and Drew that in fact, from an energy perspective, it's not necessarily a big problem. I think it's a win-win.
Yes, thank you. Question, please.
Yeah, question for I think Drew. You mentioned the security aspects of the transition. I think I'm particularly interested in hearing your thoughts on the sort of data and cyber security aspects there. We've seen the Australian government make some moves with respect to, say, telecoms infrastructure in Huawei, with choice of where it's appropriate and not appropriate to have critical infrastructure supplied. How do you see that playing out in the energy sector?
It's the same fundamental issue of a sovereign. What you're talking critical infrastructure, you're necessarily concerned with control, which can be manifested through ownership or even the source of the technology itself. So it's the same dynamics. The critical infrastructure is vulnerable to both criminal and state actors that are not acting in Australia's national interest, and the protections against that need to be built in. So the government's, I know the government's well aware of this. I'm not going to canvass responses in this forum, but it is absolutely one of the aspects of successful in managing the transition, managing that national security, particularly the digital dimension of it, is part of the policy mix.
And maybe I can add to that the shift away from a centralised generation system to a distributed system has both pros and cons. So a distributed system can act a bit more like the internet. I like to think of it as the internet of energy. You've got multiple nodes, multiple pathways, multiple redundancy, resilience arising from all those elements, which you don't have in a highly centralised energy system. So that can be a good thing in terms of the ability of the system to cope with cyber attacks on a node here or a node there. but it can also be a negative, because the next cyber attack could become from someone hacking into your fridge, which is connected to your home energy management system, which is connected to your retailer, which is connected to the national electricity grid. So there are positives and negatives. Let's not say this is something new. So in the last decade or more ago, there have been several major energy infrastructure cyber attacks. One was on Saudi Aramco. They lost 80% of the hard drives for their gas and oil distribution systems in Saudi Arabia. That caused a spike in the price of hard drives worldwide because they had to immediately fill that gap. Ukraine, we all know about Ukraine. Think back a decade ago. Russia or some foreign actor attacked the Ukrainian electricity system and brought it down by a cyber attack before they even had troops on the ground in Ukraine. This is a long time ago. So this is already with us. It's not new. We know how to deal with it, and it could have positive aspects in a distributed energy system compared to a centralised one.
If I could, just following up a little bit on that, the total costs, the integrated costs of climate change, it's very simple to get a picture of that. You have people talking to you and they can raise individual, but if you look at the total human and social and economic costs, a rise in temperature likely to change the whole pandemic situation. So we could have a whole lot more pandemics with those consequences and the interactive effects. And I haven't found a sort of plausible way of describing to people who talk to me about it. You say, well, the costs are going to be greater than not doing anything about it. Fine, well, what's the evidence? Has anyone done an integrated assessment of the human and the social and the economic costs?
So maybe I'll just, thank you so much for the question, because you've articulated what I was trying to say, probably better than me. I think it's really important that we do present that. Now, your question is, has anyone done it? I mean, I haven't read the full UK Office of Budget Responsibility paper. I've skimmed it to see what approach they took. And I think that demonstrated the kind of tools is a clumsy word, the framing to do that. But I actually agree with you. I think there's a role, and I'd be delighted to hear from someone who says that such an assessment has been done, because I don't know of it in a way that is well explained to the general public rather than being complex. I mean, I think, IPCC reports and so forth do absolutely endeavour to do this, but I'm not sure yet that we've quite got there. And this is what I meant by climate literacy. I think that there's some work to be done that tells that story in a better way. And that's why I wonder if actually working with our social scientists actually might help us, as communications experts. But others in the room, and including my colleagues here, may know of more work that's been done.
Will you speak up just a little?
Sorry. So just, we did try to look quite carefully at that as part of preparing the advice from the Climate Change Authority. And the problem isn't that there aren't estimates, they're just very extreme by one. And so you can make a plausible case, depending on which economist you talk to. Climate change would be a mild and manageable impact economically and socially, and talk to other economists who would suggest that it'd be unmanageable and downright catastrophic. But problem is there's few constraints on those models because they concern the future and the number of assumptions that go into trying to assess the economic impact of climate change. There are models that suggest a certain amount of climate change will be a good thing economically, depending on what assumptions you put in. That's my point. Not to say it is a good thing, but models can give you that result depending on what you put in. So I think there needs to be, and there isn't the equivalent of a economic climate model type of exercise that I've ever seen. So I think it's actually quite like to that kind of synthesis.
I'll just finish quickly. But apart from models, just straight data. If you look at the number of human deaths, if you look at the number of new diseases, if we just look at the total economic cost what's happened with droughts and fires and all the rest of it. Just those aren't models.
The
Those are
number of
data.
deaths has been going down. If you look at the data from EMDAT, it's actually been going down. That's not a comment on climate change. That's a comment on economic development.
Other externalities.
Society. So it's not a good proxy. For
So we might go to another question, if that's okay.
Yeah.
Tom?
Tom Worthington from the School of Computing at ANU. There was mention there of the amount of research and it's not as high as it should be, but is this research returning useful outcomes that result in companies set up, products produce, new innovations that will produce more energy or save energy in Australia? I'd suggest if it's not clearly doing that, why would government fund this research?
I'm happy to launch into that. So a lot of this is public good. So the companies won't be able to capture the economic benefit of the public good research we're talking about. So let me just talk about the public good side first. So public good research is about understanding why communities in regional parts of Australia push back on the development of transmission lines in their area, for example. Research on understanding why it is that people are reluctant to take up electric vehicles, given all the government policy uncertainty around, electricity charging stations. So that type of research is public good research, as is research on, from a computer science point of view, how do you stabilise this highly diversified, distributed electricity network with a lot of different inputs, all of which operate independently, and none of which are directly necessarily controllable. In fact, not even visible in terms of rooftop solar. So that type of computer science research is really needed, and it's very complex, and it's not going to be done by a single company that says, I've got the answer. It's going to be done by probably a suite of universities, CSIRO, other research agency experts, all working on this integration of energy problem across the board. So that's not something you can easily capture by a commercial value, but there are things. I think absolutely there are. So let me give you a couple of examples. 5B is a solar panel production company. Their aim is to be able to roll out solar panels at a very fast rate, and they do so by stacking them in a container. You pull the container out and they go zip, 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 and they're rolled out. I think the number is they rolled out a megawatt in a day with 10 people on one of their projects. That's pretty impressive. So there are great opportunities for companies like that have a niche. We're not going to produce solar panels in any quantity. We're not going to produce wind turbines, but there are niche opportunities like that.
Can I? Same argument, but framing it differently. What's the research question that is fundamental in the work that Ken talked about from a collar? And it's not a commercialisation framing at all. It's around, to me, we are going to transition the Australian energy system. To me, that's a start. This train has left the station and it's going to have to reach its destination. And I don't think many would argue with that fundamental proposition. How quickly and at what cost? And how do we maintain social licence along the way? They're the fundamental research questions, and it's in the Australian context. We're starting where we are. Other energy systems are starting at a different place. So many of these questions are uniquely Australian, and that's where the research can contribute.
Yeah, if I could jump in, the impact and the value of research has been looked at by many people, looking at a whole range of different research organisations, and it's generally found that there's a return on investment. I mean, not every research project delivers a commercialisation outcome. Obviously, if it did, it wouldn't be research because it would be a sure thing. So there's a lot of research that is done that adds to the general knowledge. It's public good, But then there are the little gems that come along and people say, oh, that's really interesting. We could pack solar cells in a container and roll them out very quickly, and that would save us a huge amount of time and make us able to install it much quicker and blah, blah, blah. So I mean, and what Drew was saying about the social license, I mean, the impact of having a greater degree of social license to roll out renewable energy is considerable, because if you can do it quicker rather than having to spend longer trying to convince people or forcing them to sort of give up their land or whatever, we've seen again and again how delay generally leads to higher costs.
Now, it's 2 o'clock, so I must draw this to a conclusion. But one observation I will make as a moderator is I was quite fascinated. Not only do we need climate literacy, we need energy literacy, because we still see the old tropes around, it's only 1.5% emissions, or the sun never shines all the time, and the wind doesn't blow. You still see these existing in the community discussions, and yet there are quite sensible, detailed answers to those issues. So I think energy literacy also is important. But I think it is time to draw this to a conclusion, and I'd like to thank the 3 people today, Ken Baldwin, Drew Clarke, and Helen Clue, for what was a very stimulating discussion. And I know this will continue into the future, and so I look forward to having another discussion with you on this topic at some stage in the future. So thank you, and also thank you for that.